Turn your faucet. Water appears. Behind that simple action sits a network so vast it would wrap around the earth 40 times over. More than 2 million miles of pipe buried beneath American streets, moving 39 billion gallons daily. The system works so reliably that most people never consider what's actually down there. This is what's inside a city's water system. Water moves through your city every second. Pumped, stored, pressurized, and delivered through a buried network you've never seen. This is the infrastructure that keeps everything running, and this video explains how it actually works. Before water reaches any pipe, it passes through a treatment facility. Raw water enters from a reservoir, river, or underground aquifer. It carries sediment, organic matter, bacteria, and dissolved chemicals. None of it safe to drink. The first step is coagulation. Operators add chemicals like aluminum sulfate that carry a positive charge. The particles suspended in the water carry a negative charge. Opposites attract. The particles clump together into larger masses called floc. Flocculation follows. The water moves slowly through basins while paddles stir it gently. This encourages the clumps to collide and grow heavier, heavy enough to sink. In sedimentation basins, the water sits for hours. The floc drifts to the bottom as sludge. Clear water flows off the top and moves to filtration. Filters catch what's settling mist, layers of sand, gravel, and activated carbon trap particles down to 1 micron. That's 50 times smaller than a human hair. Some facilities add ozone treatment here, which destroys bacteria, viruses, and compounds that cause taste and odor problems. Final disinfection uses chlorine or chloramine. These chemicals kill pathogens and remain active as the water travels through miles of pipe. The residual disinfectant prevents bacterial growth all the way to your tap. Treated water enters the distribution system through transmission mains. These are the largest pipes, sometimes 4 feet in diameter or more. They carry water from treatment plants to different zones across the city. From transmission mains, water moves into distribution mains. These branch through neighborhoods like arteries. Smaller service lines split off to individual buildings. The entire network forms a grid with multiple paths for water to reach any location. If one main breaks, water reroutes automatically. The pipes themselves are cast iron, ductile iron, PVC, or concrete, many installed decades ago. Roughly a third of all water mains in the United States are over 50 years old. That's 770,000 miles of aging pipe still in service. The average water main fails after 53 years. Valves control flow throughout the system. Gate valves can isolate sections for repair without shutting down entire neighborhoods. Pressure-reducing valves protect areas at lower elevations from excessive pressure. Air release valves let trapped air escape, preventing pressure surges that damage pipes. Water doesn't flow uphill on its own. Pumping stations push it where gravity can't. High-lift pumps at treatment plants send water into the distribution system. Booster stations throughout the city maintain pressure in areas far from the source or at higher elevations. These facilities run continuously. Variable frequency drives adjust pump speed based on demand. During morning showers and evening cooking, pumps work harder. At 3 in the morning, they throttle back. The goal is constant pressure between 50 and 80 psi at every tap. Backup generators sit ready at every major station. If power fails, pumps must keep running. Loss of pressure allows contamination to enter pipes through cracks and joints. The system cannot afford downtime. That elevated tank you see from the highway serves 2 purposes: storage and pressure. Height creates pressure. Every foot of elevation produces 0.43 psi. A typical water tower stands 130 to 200 feet tall, generating 50 to 80 pounds per square inch at ground level. No pumps required. Gravity does the work. During low demand periods, pumps fill the tower. During peak demand, water flows out to supplement what the pumps provide. The tower acts as a buffer, smoothing the difference between supply and consumption. It's also emergency reserve. If pumps fail, the tower keeps water flowing while crews respond. Most towers hold enough water for about 1 day of normal use. Fire hydrants connect to the same system, and a major fire can drain storage quickly. Insurance rates in communities with water towers are typically lower because the guaranteed pressure means hydrants will work when needed. A service line connects the distribution main to your building. It passes through a meter that measures consumption. Inside your walls, smaller copper or PEX pipes branch to every fixture. The pressure you feel at the tap comes from miles away. From the treatment plant, through transmission mains, into distribution pipes, boosted by pumping stations, stabilized by water towers, and finally through your service line. The entire system balances supply against demand in real time. The United States experiences roughly 260,000 water main breaks every year. That's one break every 2 minutes, somewhere in the country. Repair costs exceed $2.6 billion annually. Another 6 billion gallons of treated water leak from aging pipes every single day. Utilities replace pipes at about 0.5% per year. At that rate, full replacement would take 2 centuries. The infrastructure needs more than $625 billion in investment over the next 20 years just to maintain current service. And yet the water keeps flowing. Treatment plants run around the clock. Pumps cycle on and off. Towers fill and drain. Operators monitor pressure and quality from control rooms. The whole network functions as a single machine, invisible and continuous. Next time you turn the faucet, remember what's behind it. 2 million miles of pipe. Thousands of pumping stations, chemical treatment running constantly, infrastructure older than most buildings, still delivering clean water on demand. That's what's inside a city's water system.